just want to do one real world application problem so you can kind of get a better sense of how the matrix math works, and then discuss briefly why they're so powerful for computers specifically, which is where we generally use matrix math. So in this problem, two softball teams submit equipment lists for the season. A bat costs 20, ball 5, uniforms 40, and so use matrix multiplication to find the total cost of the equipment for each team. So just think about how you would do this. You would go through 13 bats times 20. 42 balls times 5, and then you multiply, and you would probably do it separately for each team. And so it might not take you that much time, but what if you had 100 teams, right? And so you do each thing separately, and you'd be duplicating all of that work. So now think about another way you could do it on the computer, and that would be to use these matrices. And so notice what you would do is create an equipment matrix where you have two teams, and you have your equipment items that you need. So in this case, we have a 2 by 3 matrix. And then you would multiply that by the cost that you have for each item. So in this case, we have our 3 rows and 1 column. And again, the columns in the first match the rows in the second. And so it will work. We can multiply them. But to give a little context, look at what those 3 represent. The 3 represent the columns, but they represent the equipment items that you need. The 3 rows, in this case, represent the equipment items that you need. And so it should add a little more context about why those have to match up, right? If you had 3 equipment items in the first matrix, but only bats and balls, only 2 in the second, you obviously couldn't find a total cost because you'd be missing a piece of information. You'd be missing the cost of the uniform, and so obviously you couldn't solve the problem. So this should give you a little context, a little insight into why those two things need to match up. Okay, I'm going to fast forward through the math on this, okay? So the computer would just multiply the first row times the first column, the second, and you'd go on, so forth. But the answer, what you'd get here, would be the total cost for the women's team. And here would be the total cost for the men's team. So remember, the computer, once you set the rules for the computer, this is where we use it, it's going to crunch through those numbers really quickly. So now there's a couple benefits here, because you're thinking, well, that would have taken me just as long as doing it out. However, imagine you had a league with 100 teams. All you would have to do is add those teams there. And remember, you already have your costs for these things. You don't have to do anything to that. It's already set. And the computer just crunched those numbers just as easily, and you'd get more answers over here. You could have 50 teams, 1,000 teams. It doesn't matter. The computer's going to crunch through all that data very quickly as long as you set it up in this nice structure. And that's why we use the matrix, because it's a good structure to input data to a computer. And once you give it data in a nice structure and define the rules, it can crunch through tons of data super fast. Another benefit is this. Notice you could do your 100 teams, but you'd only have to write the 20, the 5, and the 40 one time. You wouldn't have to do 13 times 20, 42, you wouldn't have to do that. You put those numbers in one time, and that reduces the number of total data you need to give the computer. And you should all be familiar with how when you try to tax a computer or too much stuff going on, it slows down. And when you have fewer things running on your computer, it speeds up. And if you go down to the bottom level, you can think of that as just bits of data. And so the least amount of data you can give your computer to solve a problem, it's going to run faster. And that's another benefit of using a matrix, is that you can pass the least amount of information needed to your computer, and it can streamline the amount of stuff on your computer, and so it can work faster. The other thing is it's super easy to edit this. Imagine we wanted to change, imagine next year the item cost change, and the bat's 25, the ball's 4, the uniform's 35. No problem. You just type in 25 instead of 20, 4 instead of the 5, and 35 instead of the 40, and the computer's going to update every single thing just like that. And you're not going to have to go through and do each thing separately. You just have to update those one time because you only inputted them one time. So I know it's always a kind of a quick overview, but you should see two things there, right? One, why these two things need to match up. Because if you didn't, you wouldn't have had a cost for each of the items. And if you didn't, then you obviously wouldn't be able to find the total cost. Second, you can see the power of that structure, how you can do not just 2 teams, but you could do your computer could do 100 teams just as quickly as long as you give it to it in that nice structure. And that's why we use matrices. Okay, one last example, one last point, and we are done. So let's multiply. All right, so in this case, I'm thinking, okay, well, I'm going to get something over here. And I know I'm going to start with, like, what I'm going to end up with is my first row and my first column. I'm going to multiply those. So I have my first row. Well, I only have 1 row, so that's pretty simple. Multiply it by my first column. Only 1 column, so that's simple. Okay, so I'm going to do my 5 times my negative 3. 5 times negative 3, right? And I'm going to add to that 1 times the negative 2. So 1 times negative 2. And that is negative 15 plus negative 2 is negative 17. And wait a second, I'm done, because there's nothing else. I already multiplied my first row by my first column. So notice when we did a 1 by 2 matrix, and we multiplied it by a 2 by 1 matrix, we ended up with a 1 by 1 matrix. Only 1 row, 1 column, which in this case is 1 element, right? But so just back to the beginning, you know when you see what you need to multiply, what you're going to end up with, okay? So the dimensions of your product are going to be the number of rows in your first matrix times the number of columns in your second matrix, M by P, which is exactly what we saw here. We ended up with a 1 by 1 matrix.